Okay, now I'm gonna start running this from the main program. So back into the main program. Um, Now all this parametric programming is to simplify the programming. So whenever I call uh, machine to table and I write 2 into it, I know that the path the robot will follow is this. And whenever I issue a machine to table with a 1 argument, I know the robot will go from this point and it go through the table station and back into the uh, conveyor station. So this is how I control the program runs. I just call the program and pass down some arguments. This is very common with other programming languages, like say Python or Java or C Sharp. You pass on arguments to functions, and that's how it simplifies and makes a program readable and understandable by anyone, to break it down into smaller functional units. And it's the same case for the load machine. Load machine down here is a program to which I pass down a register. This register starts with a value of 1, and that value is incremented after the part is offloaded. So once the part is offloaded into the conveyor, placed here, the count on spindle count goes up by 1. And if the count is greater than 4, then the program exits or terminates. It goes to label 2, which then terminates the program. But as long as the count is less than 4, it will go back to label 1. So this program will complete a 4 spindle cycle. But this is, and I can add another label here that will encircle everything, and that label can be tied to a background logic to which I can have a start cycle, end of cycle stop, and even add later on a homing, auto homing feature for this. So right now they're gonna disable the teach panel. It's now disabled, and I'm gonna run this program now. So robot will start to get up, picking apart from the conveyor, the in-feed conveyor, and then it's gonna go and load spindle 1 right here, and it's gonna go to the table and grab, and I can watch here the actual registers changing phase. So this is the spindle to do now. It's now doing spindle 2, and it's gonna go and do a spindle, I know not here, but spindle down here. Count is 1. That's gonna go, which is actually 2, because the function adds 1 to it. It's gonna go now into spindle 3, and you can see that it goes into like weird fashion, rotating the part. That is so some dirt from the parts fell off. So it's got that weird rotational motion. So the part, as it goes out, rotates to detach some components from it, like spin it out, brush it off or something. There's something that needs to be probably fine-tuned later on. But like I said, this is the main structure of the program. The program completed all 4 fixtures, and I can execute it again and show you again what it does from a different perspective. So if I were to be, actually the repair is going to be standing like this, looking at the machine like this normally. So it's going to load the parts. Actually it's going to be standing not here, but probably like here, probably standing here, and going to be loading parts, and the robot's going to go and feed the parts into the welder, and then etch the parts, and then place the finished parts into the outfeed conveyor like that. Draw a part from the infeed conveyor, parts coming here, and so on, and then it's going to go that weird rotational motion. It's going to go there and load a part to be etched, and back into the infeed, grab another part. And this is the outfeed, sorry, this is the outfeed, this is the infeed, parts coming this way, parts going out that way to the next operation. So this probably needs to be fine-tuned. Like I consider some dimensional changes on this, given that this fixture is not located at this position right now. This machine here is really large, so probably we use this as the anchor object for the whole cell, and then relocate this machine. This machine is actually standing not here, but behind this machine, like somewhere behind, like the dishpan here. And this conveyor is not yet installed. There's something I need to design with an integrator for us, because this is probably going to be made of aluminum extrusion and some servo drives, but I'm going to be programming this. I just need it to be built externally because we don't have any machinery to make it, so it's going to be commissioned to someone outside the company. This currently we want to be modifying the etcher ourselves, adding some clamping to it and some signals so the robot knows it's been etched or passed or whatever. Probably a reject chute so we get our reject parts out. But this is the whole concept. Basically, a fully automated spot welding etching cell, and it's far less expensive than a proposal we had from a company that was like $300,000 or so, and we can accomplish this by a third of the cost. The robot is like $46,000, and we can probably get the rest for another less than 400 or something. So we can do it. All we need is the actual green light from management. So hopefully this materializes into something real and not just a simulation. Well, thank you for watching, and stay tuned for more.